Good morning, good evening, wherever you are. Thank you for joining the Serverless Practitioner Summit. My name is Tom Kerkhove, and I'm happy to have you in my application autoscaling talk, where we use Kubernetes Event-Driven Autoscaling, which makes application autoscaling that simple. So my name is Tom Kerkhove. Like I mentioned, I'm an Azure architect and R&D manager at Codit. I'm part of the Azure user group in Belgium, where I live near Bruges, and I'm one of the maintainers of KEDA, and also work on Prometheus, Arcus, and other projects. And you can also find me on my blog. Now, today I will be talking about application autoscaling with KEDA, but first let's have a look what it looks like in vanilla Kubernetes. So if you have a deployment, you can add a horizontal pod autoscaler to scale on CPU and memory. But in a lot of scenarios, that's too limiting because you depend on external metrics from the systems that you use. That's where Kubernetes custom metrics comes in, where you can use metric adapters to basically bring the external metrics inside your cluster and use them there. Now, the problem is you can only use one metric adapter. So that means you need to choose which one you want to use. And then you need tools like Prometheus to basically bring the metrics into that one system. Now, that's a bit cumbersome, and you need to be a bit of a Kubernetes wizard to understand all of that stuff. So we're trying to make that simple with KEDA, where we basically allow you to auto-scale deployments and jobs without having to worry on how to do it. You just have to tell us what you want to scale on and when, and we'll handle everything for you. To do that, we have more than 20 scalers and allow you to use your own scaler by building an external one which supports push or pull. We also use production grade security, where you can use things like pod identity to really eliminate any secrets. And one of our key features is basically scaling to zero, so that if there is no work to do, we will basically free up all the resources for other applications. And we're happy to be one of the CNCF sandbox projects as of this year. And our motto is really to focus on scaling our application and not the scaling internals. So if you take a step back on what we saw before, we can basically get rid of all the gray part and basically just install KEDA, which brings a variety of scalers out of the box who know how to integrate with those systems. Then from an application perspective, we will create scaled objects, which define the workload that we want to scale on and the scaler that we want to use. And KEDA will then use a scale controller to monitor all the scaled objects. And if there is a 0 to 1 scaling action, it will create an horizontal pod autoscaler and will feed the metrics to scale your application further. Okay, we have a lot of scalers. We're cloud agnostic and vendor agnostic. We basically support a ton of great products and services, and we're open to any of them. So if you have any suggestions, just let us know, but let's just show how it's done. So here I have a portal which basically shows queue depth for orders. In this demo, I'll basically auto-scale based on this queue depth. So on the top right, we have one processor, and we will basically add more messages to the queue so that we will auto-scale based on that. So if I get the pods and see if we have an active one, here you see that we have one instance running. I will just do a logs, and you see that now it's pretty idle. So here I will generate some work, and basically I will queue 300 orders. You see that the processor instantly starts working, and our queue is piling up. But because it's one instance, it's super slow. So we want to scale that out. That's where KEDA comes in. At KEDA, I can define a scaled object where we basically have a scale target, which is our deployment, which we reference by name. We define the minimum and the maximum replica count, And we define the triggers that we want to use. So in this case, we're scaling on service bus metrics from Azure, where we say this is the order queue. If there are more than 5 messages, add an instance and keep on scaling. And here we're adding this the authentication, trigger authentication, where basically we are decoupling the scaling from the authentication so that the operations people can basically provide you with secrets. In this case, it's coming from a Kubernetes secret. Now, as you can see, it's still trying to keep up, but we will help a hand and we will basically apply our autoscaling. So when we run that, you will see that it's creating the scaled object, the trigger authentication, and the secret. And if we now start watching the pods, you will see that KEDA will basically add more instances. How do you install KEDA? It's very simple. You just do a helm install, and you see that that's how I installed it here. And now you can see that it is already adding more and more instances. And if we do git deployment, it will be adding more and more, and you see that it's already at 4 instances, and it will go up to 8. When there is no more work, it will basically reduce the whole deployment to 0 to optimize for the cost. That's how simple it is. Just apply the scaled object, and we handle the rest. So how does it work? KEDA basically builds on top of Kubernetes and extends Kubernetes by using the horizontal pod autoscaler under the hood. And if we want to scale down to 0, we remove the HPA and we basically scale the deployment to 0. KEDA itself has a metric adapter that has all the scalars and the scale controller itself, which manages all the components. If you want to get started, just use Helm or Operator Framework to deploy it in your cluster, and you're good to go. Now, KEDA fits in a bigger autoscaling picture of Kubernetes itself. So we have KEDA who does the application autoscaling. But if the cluster is full, you will still be using the Kubernetes cluster autoscaler to add another node and basically scale the application across those nodes. If you're using virtual nodes and virtual kubelet, you can even handle bursts and scale outside of the cluster. And then the beauty of KEDA is also that if there is no more work, it will be removing all the instances, which means freeing up resources, and the cluster can rebalance the workload so that it can cut some compute and save some money. Our community is growing. We have a ton of great users like Apache Airflow, Astronomer, PureFacts, and more. There might or might not be a super cool user being announced in the next couple of weeks or months. So stay tuned for that. And we have a growing community with people like Microsoft, Red Hat, Codit, IBM, and others. And you can join our bi-weekly stand-up meetings if you want. We're working very hard on KEDA 2.0, allowing you to scale on other custom resources which are not a Kubernetes deployment or job. And we're basically going to surface more of the HPA and the standard metrics like CPU and memory so that you can scale on those as well. We'll allow you to use multiple triggers per scaled object, and we will surface our own metrics so that Prometheus can use these. And you can manage KEDA with the Go client. We're also building a community around the external scalers. So if there is a scaler that's not supported, let us know so we can consider it, but you can still build it yourself and add it to our community. We're also evaluating if we should integrate with the cluster autoscaler to provide a more seamless approach, and we will also consider integrating with external metric sources so that you can just give us metric values and we can scale accordingly on those as well so that you don't have to build your own scalers. Thank you for joining, and I hope I see you around using KEDA or contributing to KEDA. Thanks.